5-axis alignment. One of the important things to remember in a 5-axis alignment is that you have to go through all of the steps in order for the machine to get all the information. So we're going to start out by aligning a plane, and we are going to set an offset 506. To align a plane, we need 3 points. So we're going to take a point down here near us at this end, then we're going to move down to the opposite end, take another point near us, and then we're going to come back toward the middle and go up and take a third point. So now we always jog out to a safe place. We've got 3 points saved, and we're going to set work offset. Okay, activate work offset now. We're going to say OK, and we're going to press NC start to set the probe perpendicular to the plane. Okay, and the machine's going to move. That's no big deal. What we want to do is take note of these numbers right here. Those numbers are representative of the plane. So now we're sitting flat. We're going to go back to our swivel cycle. We're going to re-swivel right back up to where we were. As soon as it's in position, we're going to go to measure workpiece, and we're going to choose a line and edge. And we are going to rotate the coordinate system, measuring in the Y negative. So come down here. And we position. We take our first point. We take our second point. And we say set work offset. Now let's just check our offset. The 506. We'll go to the details. We've still got our rotations in there. So we aligned that edge. So now we go back to here. We're going to find a point, and we want the center of the material roughly. We have to find that point. So we're going to go down to our center. We're in measure workpiece. We're going to go rectangular spigot, and we're going to let it find the point on the surface of the material at the geometric center. And I wasn't close enough to center. So we'll try again. There we go. It comes through. It's going to check both ends, and then the top and bottom. The important thing to remember here is that when we aligned the plane and aligned the edge, it knows the angle at which the face of that part is at. So it is doing the math. It's doing all the trigonometry. Now you can see our work offset values are much, much different than they were. And these are the measured values, so if you need to know the length and width of that material, there it is right there, what it actually measured. So now we go back out here, we hit the back button, we come up here to a single edge, and we're going to pull our Z. Now here's the values that are in the work offset right now. Okay, we can double check that in the offset. There's the numbers, X, Y, and Z numbers that are in the offset. We go back to our single Z. We're going to put the surface of the material 20 above our 0 point so we can clean the bark off. Now, we're just going to take a point on the surface of that material. We are going to jog out of harm's way. Now look at how different the numbers are in the work offset. Go back to our work offset. Those numbers changed dramatically because it did the trigonometry from the center of the rotation up in Y and forward in Z to get to the point on the surface of that material. And that is roughly 8 inches above the table and 6 inches toward the spindle from the center of rotation.